Hey guys, welcome to derivatives of inverse functions. This probably doesn't sound like exactly what it is, but we'll see how we do. We're going to start off, this is the formula. Okay, so f is a differentiable function as 1-to-1 with an inverse. Those things mean the same thing. And you have g is f inverse of x. And so b is some number. And basically they're saying if g is the inverse function, the derivative of that inverse function equals 1 over f prime at g of b. So there's like a lot of ways to write this with g's and f's and f inverses and h's. We're going to start with this way, and I'll, at the end of this little mini proof here, I'll give you an example of another way to write it. But pretty much you can think about it like this. You may recall that if I compose a function and its inverse, so here we have f is a function and g is its inverse. So if I compose these functions, I say f of g of x, that's got to be equal to x. That's what the inverse does. It like, the f does something to the function and the f does something to x and the g undoes that thing. That's what the inverse is. It like undoes the thing that the function did. When that happens, it's like you like square it and then you take the square root. Those are inverses and you end up with just x. Or you like add 3 and then you subtract 3 and that just brings you back to x. So this always happens when f and g are inverses. This is kind of a definition. If f and g are inverses, then f of g of x equals x. Now that we know how to take derivatives of compositions of functions, we can do the derivative with respect to x of both sides of this equation. We'll end up with a derivative with respect to x of this composition equals a derivative with respect to x of x. I said the derivative of both sides of this thing. And so now this is like the chain rule in its most normal form. It's the derivative of some composition. And I know that that then is, you do f prime at g of x times g prime of x. This is just the chain rule. This like exactly how we learned it the first time. The derivative of some composition, it's a derivative of the outside at the inside, leave g of x there, times the derivative of the inside. This is the chain rule. The derivative with respect to x of x is just 1, which means if I want to, like, this is the derivative of the inverse. G was the inverse, this is derivative. That means that g prime of x is 1 over f prime at g of x, which is exactly what this says. These two things are the same thing. This is saying, they just put a b because there's like, if b is just some number in the domain, we're just going to call it x for now. So the derivative of the inverse of f is 1 over f prime evaluated at g of x. And this is like a formula you can use. You can always remember this formula. Not every problem is phrased in this way where it's just f's and g's, which makes this a little bit tricky sometimes for people. Like you lose, like, well, what if they said this was f inverse and f and not g and f? So it gets a little bit confusing. The other way to write this, that's probably the most common other way, is that the derivative of the inverse of f inverse prime, is 1 over f prime at f inverse of x. This is basically, these are the same formula, but I'm replacing g with f inverse. If I do that, I get this. So I take this formula, the g prime equals 1 over f prime at g. I just replace g with, oh, I should have wrote, that's not right. Sorry, that's confusing. This should say, oh boy, it's too thick again. This should say f inverse. G is f inverse. So if I just replace g with f inverse, I get this formula instead of this one. And like you could name these things whatever you want. You could say that what if h is the inverse of f? Then this is h instead of f inverse. So there's a lot of ways to write this, but we're going to see in the next couple examples like how we actually put this into play. And there's one thing that's really important to remember, which is this. Like if, let's say f of 2 is equal to 1, just some function, some value. This should lead you directly to the statement that f inverse of 1 equals 2. these things have kind of the same meaning. So like if I have a function at some point, at some value of x, and it equals some number, it doesn't matter what these numbers are. I just pick 2 and 1 out of thin air. And that means f inverse of 1 equals 2. And we're going to use this fact a lot to figure out this inside part, is what this boils down to. And if, like I said, f of 7 equals 11, then f inverse of 11 must be equal to 7. These are like, they're like little pairs. They go together. Like the inverse and the function, they switch domain and range. So you switch the x and the y and you get these things. And if I say f of a equals b, then f inverse of b is equal to a. And this is just how inverse functions and functions work. They switch the domain and the range. So this is our kind of our definition for the derivative of the inverse. This is, like I said, it's like a formula. And the tricky part is usually like figuring out what this inside, what f inverse of x is, because they don't always give you that. So here's an example. Here's f and g, and their function differentiable everywhere. That's fine. G is the inverse of f, which is exactly the situation we had here. We said g is the inverse of f. So we can actually use this formula exactly the way it is. And then they give us these pieces of information, which we're going to use to figure out all the things in our formula. So let's just remember g prime. I'm just going to write down the formula again. G prime of x equals 1 over f prime at g of x. That's the formula. R's, we're trying to evaluate it at -2. So I'm going to replace all the x's in my formula with -2. G prime of -2 equals 1 over f prime at g of -2. So the problem here is, like, if I knew what f was, I could take the derivative and maybe plug a number into it down here, but I don't have f. All I have is these 2 pieces of information, but that's enough. It tells me that g of -2 is 5. So this is really 1 over f prime of 5. I just did this. I used this fact right here. I'd replace g of -2 with 5. And then we have f prime of 5. They told us is -1/2. So this is 1 over -1/2, which is -2. That's like you flip the bottom and multiply, and you get this. So this is about as easy as these problems get, because you didn't have to really do anything to figure out this g of -2. But it's good to see how the formula works. Like we have to figure out this thing first and then evaluate f prime at that function. Here they just told us what that was. It's possible they could give us a formula for f, and we have to take the derivative and then plug this value in. But here they just gave us all the information we needed. The big step here was remembering to write this down, knowing that this is the derivative of the inverse function. Okay. So moving right along, here's another one. This one's worded a little differently, but it's the same idea. We have y is f of x and x is f inverse of y. That just means like y is the function and x is the inverse function. So they tell me that when x is 1, y is 4, and the derivative when x is 1 is -3. That's what. This is just giving me like a point. This is a point 1, 4. And this dy dx equals -3 at x equals 1 is telling me this part right here, the part I'm underlining in green, is telling me that when x is 1, the derivative of y is 3. That's like saying f of 1 equals -3. Could f of 1 is 4. Oh, sorry, f prime of 1 is -3. And then this dx dy at y equals 4. This is like asking you this. And this is the part that I think is more confusing. This part right here is asking, it's like what the question is asking. It's saying like dx dy is the derivative of the inverse. X is the inverse function. So the derivative of the inverse, f inverse prime. They want to know what this is. So we have a formula for the derivative of the inverse. The derivative of the inverse is 1 over f prime at f inverse of x for whatever x I'm using. And in this case, I'm using 4. So I'm going to write equals in this particular case, because they said at 4. So we got f inverse of 4, and we can figure that out by using this piece of information. If f of 1 is 4, then f inverse of 4 is equal to 1. And that was what I said before. I'll scroll back real quick. This thing I showed you where I was like, you can switch the x and the y's when it becomes the inverse. If f of 2 is 1, then f inverse of 1 is 2. And they use that here. They give you f of 1 is 4, which you can translate into f inverse of 4 is 1. And that's the thing that's right here. So this is like saying 1 over f prime at 1, because f inverse of 4 is equal to 1. So that essentially gets plugged in right here. And again, I don't have a function. They don't give me like a formula for f, but they do tell me that, remember I wrote this down, this dy dx equals -3 when x is 1, tells me that f prime of 1 is 3. Oh, sorry, it's -3, which means f prime of 1, -3. 1 over -3, which is -1/3, which is choice A. So this one had kind of 2 wrinkles in it. Wrinkle number 1 is that they didn't call them f and g, which is kind of annoying, but you can always rewrite them with f and g if you want to, or you can use them this way. What sometimes throws people, so that was one thing that was different, was that the functions were named differently. But the other thing that was different was that here, I had to do this to figure out that thing. When I was talking earlier about like what the challenges are with using this formula, often the challenge with this formula is figuring out what this thing is. And so like, I don't know how challenging you thought that was, but here, if I'm like, what's f inverse of 4? Well, if I know f of 1 equals 4, that means f inverse of 4 equals 1. So you have to do this little switch here to get this thing in there. And that can be confusing. I'm well aware that can be confusing. So we're going to do more practice with this, I promise. But this is a pretty common way that these things are done, where you have to like do this switch before you can get the final answer. And then I'm going to do one with the table, and then I'll break this video and we'll come back and talk about inverse functions, about inverse trig functions. So here we have a function g and its derivative. They're showing us these values at x equals -3, -1, 1, and 4. The strictly monotonic thing tells you that it's 1-to-1. Don't worry about that. It just means that the inverse exists everywhere. So it says find the derivative of g, the derivative of the inverse of g at 1. So I would, again, I think it's a good idea, particularly at the beginning, to write down the formula each time. The derivative of the inverse of g is 1 over g prime at g inverse of x. And I can go back to our original formula where I was like, the derivative of the inverse is 1 over f prime at g of x. That's the same thing here. The only difference is that instead of f and g, I called it g and g inverse. So the notation, particularly when I switch the original function to g, it's like hard to compare to the original. But the derivative of the inverse is 1 over the derivative of the function at the inverse of x. So the function, quote unquote, here is g. So this first part, this I can use for a and b, right? Because it's the same, it's g inverse prime both times. So I'll just write that for either one. And now we'll do part A. I want g inverse prime at 1. So I'm going to do this thing, but I'm going to put a 1 where the x is. So it's 1 over G prime at G inverse of 1. So the question, like I said, it's often challenging, is what is G inverse of 1? Well, I don't know. So let's imagine that G inverse of 1 is equal to X. It equals some value of X. I don't know what it is, but it's some value of X. And I know that because this is the inverse of G, that this is equivalent to writing G of X equals 1. Right? When I switch from the inverse to the function, I switch this one and this one. So G of X equals 1. Well, what value of X, that top row, gets me 1 for G of X, this middle row? Well, if I look, when the middle row is 1, the X value is -1. So that's the thing that goes in here. What is G inverse of 1? It's -1. So this thing is 1 over G prime at -1. And that is actually just in my table. If I have x's, this is just G prime when X is -1, X is -1, G prime is -1/5. 1 over -1/5, which is equal to -5. And that's how you do part A. So just to kind of recap what we did there, we did the derivative of G inverse is 1 over G prime at G inverse of X. This is the formula. It's like a little bit different because there's no F's in this one, but it's the same idea. The derivative of the inverse of some function is the derivative of that function evaluated at the inverse of some value of X. So like it's always the inverse here, the derivative of the function, and then the inverse on the inside. It doesn't matter whether these are F's or G's or H's or whatever. It's always just the derivative of the inverse is the function's derivative at the inverse of that function. So I can do a very similar thing for G inverse prime of -3, which is part B. It's going to be 1 over G prime at G inverse of 3. Oop, -3. Now I'm going to do the same little trick up here where I'm like, what the hell is this G inverse of -3? That's always kind of the hard thing to figure out. So I just set it equal to X. -3 is X, which implies that G of X should be equal to -3. So I go back up to my table and I'm like, what value of X makes G of X -3? Well, when G of X is -3, X is equal to 4. So that tells me that G of X equals 3 means that X is 4. So G inverse of -3 then is 4. So this thing leads me to 1 over G prime at 4, which equals 1 over, and I'm just really hoping that this is in my table, and of course it is, because this 4 is in the table and G prime is right here. So I go back down here. G prime of 4 is -2. This is equal to -1/2. So these are my two answers. So there's more practice like this coming up, but we're going to talk about derivatives of inverse functions here in the next video. So stay tuned.